Hello YouTube, this is Kentucky Prepper 1792, and this video is going to be about making soap. If there's ever a grid down situation, SHTF, where logistics have been broken down to, supplies aren't getting around from where they're made in the factory to wherever you need them to be, then making soap might be something that you need to learn how to do. So these are the basic supplies we have. We have oil. This is pure olive oil. Right here we have distilled water. I use distilled water because tap water has a lot of salts. You're going to have a lot of different ions, magnesium, iron, copper, who knows, and that could affect your chemistry, and the salts are going to affect your soap. This is palm oil, just because olive oil and palm oil are going to be used in my recipe. This right here is lye, 100% lye. This is drain opener, but Rudo, the company that makes this, they have stated that you can make soap out of this. It's 100%, which probably means it's like 99.9%. I bought this because it was a good deal. But you can also go to Fisher or whatever catalogs to get your soap, and it's becoming increasingly harder to get because everybody's scared of meth heads and people making illegal substances. Which, if you don't have lye, which is sodium hydroxide, you can also use calcium and potassium hydroxide, but those are going to make you different kind of soaps. But if you don't have this, you're not making soap. There is no such thing as soap that's not made with lye. Somewhere in the process it was made with lye. This is an essential oil. This is lavender. I don't know if you can see where it says lavender on there. Maybe not. But it's essential oil. I have wax paper that I'm going to use to line my mold. I'm going to be using PVC molds, as I'll show you in a second. And this is a little hand blender. It just makes the process go very fast because we're going to be mixing oils and water together, which the water is going to have your lye, your sodium hydroxide, and oil and water don't mix. So you're going to have to make an emulsion with the stick blender so those molecules will come in contact with each other because oil and water don't mix, and your two reactants are going to be fatty acids and your sodium hydroxide, which is going to be in an aqueous water environment. So this is some of the materials that we'll need, and I'll show you some more. Here are some of the other supplies that we'll need. Here I have something that I'm going to make my lye in. You don't want your lye to be in a reactive container like aluminum. Do not make your lye in aluminum or metals in general. I recommend using plastic. You can use stainless steel, but this is easier to come by. And I have, a warning on it, just because I don't want this to be mistaken by a guest to come over, be like, oh, here's something I can make Kool-Aid in or whatever. I actually weighed it because that just makes the measuring easier for later. This is my reaction vessel. This is a food safe polyethylene, high density polyethylene bucket. I'm going to be dipping this in a hot water bath because if I use a stainless steel reaction vessel that I'm going to be heating on the stove, then it's going to be hotter at the surface where it comes in contact with the burner. So if I put it in a hot water bath, I know as long as this is immersed in hot water, it can't increase past the point of water as a liquid. So if water boils, it can get hotter as steam, but if it stays in water, it's not going to get above 100 Celsius or the 212 and something Fahrenheit. I'm used to Celsius, being trained as a chemist. You need a scale. The more decimal places you can get, the more confidence you can have in how well you're weighing something, because little measurements can make a big difference. Little errors in measurement can make a big difference, is what I was trying to say. The larger your batch, the less decimal places you're really going to have. And that would have to do with significant digits. Look that up if you don't understand what that is. This is a, I don't know if you can see this. It measures in ounces and grams. I use grams because, hey, I'm a, my science expertise has been learned through the metric system. It's much easier. But you can see it says 0 or grams. If you're going to get a precise one, they can really cost you a lot more money. This is a postal scale or dietary scale. So you saw my wax paper. What I did for my wax paper is I just made like a little covering and I taped it together so it fit as flush as possible with my PVC. PVC is going to be relatively unreactive for what we're going to do. The less wrinkles you get in it, the better. Let's see if I can get it back in here. I wanted to show you. But this makes it so it's much easier to get out once the soap is a solid, because it can be pretty sticky when it's, you know, after it's made. So I have it in there. I got it taped. This is PVC pipe. It's a 3-inch in diameter PVC pipe. I just bought a test cap that I put on there for the bottom. These things are crap. They break a lot. I don't know if you can see how that's got a little, broke even more. A little crack in it. So I'm going to put it on here, and I'm going to put like another cap just on the bottom, just so it won't leak out of the bottom so much. It'll seal itself alright. And I have another one that I'm going to use for that. Here's the tape. You know, I'm going to put my essential oil in here and let it, you know, seal it up in there until I'm going to use it so it doesn't evaporate away or whatever. I'm going to put my lye in here. I'm going to measure it in here. It is, if you're mixing it with lye, don't ever use it for cooking or eating or what have you. And I'm going to put it in here. Something you're going to want sealed, because lye is, I think it's hygroscopic is the term, I believe. It'll just suck moisture out of the air, and then like your lye will weigh more but still contain the same amount of sodium hydroxide molecules because it's just sucking it out of the air, and they'll lead to inaccuracies. And let me show you my reaction vessel that I have here. It's not very high-tech stuff, guys. Here's my reaction vessel. It's just a stainless steel soup pot. I got some water in there heating up. And I'm going to put it on the stove. And an important thing to have, for sure, are goggles. Many people are familiar with acids, and you think about how acids can, like, you know, burn your skin. Well, bases are kind of like the opposite of acids. They are higher on the pH scale, and they pretty much take away hydrogen atoms from substances, when acids add hydrogen atoms to substances. So more people go blind by getting bases in their eye than they do acids. You get lemon juice in your eye. I believe lemon juice has a pH around 2 or 3. Check me on that. But it's going to hurt, it's going to sting. But on the opposite end of the scale, if you get just a little bit of base in your eye, and it's, you know, pH of, you know, 10, I guess, comparatively, let's say, 12, that's going to be bad for your eyes. You're more likely to go blind by getting base in your eye as opposed to acids. Anyway, something I learned working in the chemical industry. Have these. don't start without them. This does take a lot of planning. You want a clean work environment, especially when you're working with lye, which it can burn you. You're going to need to be very careful. You're going to have to be clean. You're going to have to clean up afterwards. I think it took me like 2 hours of preparation and getting all my ducks in a row for this. Maybe that is a long time, maybe not. So just make sure you're ready to commit to this, because once you start the reaction, you need to finish it. It's not something you can easily interrupt and start later, in my opinion. There's a lot more information, a lot more resources out there. A lot of library books, there's a lot of YouTubes, there's a lot of websites that will teach you how to do this, but I think it's important for prepping because cleanliness is a good thing.